Hello, welcome to this video. In this video, we are going to solve KodeCloud's CKS lab challenge number 3. Let's look at the problem statement. This is a two-node Kubernetes cluster, and using Kubebench, we need to identify all the security issues and fix for both control plane as well as the worker node. So looks pretty straightforward. We need to set up the Kubebench, run the Kubebench report, and then fix various cluster components. So let's start. Let's open 2 or 3 terminals. Let's set up our aliases. Namespace, maybe let's just go to the kube system namespace because we are concerned with the cluster components here. Likewise on other terminals. All right. So when we click on this Kubebench icon, it gives us more instructions. It talks about installing the Kubebench first. And for that, they have given a link to the Kubebench installation document. And once we do that, we will proceed to fix the Kube API server related issues first. We will see if changing Kube API server breaks it. And if it is broken, then how we go about debugging the issue. Because ultimately, Kube API server is the heart of the cluster. So if API server breaks, nothing will work at all. So we will see how we go about debugging a broken API server if it breaks, and then how we go about fixing it. Let's start with the first step first, which says download the Kubebench and extract it under /opt file system. So not on the root, we need to create a /opt, and then we need to follow the instructions and run the command setting the config directory to opt/cfg and this config YAML. So basically, when you install Kubebench under /opt folder, it will be expecting the config file to be present in /opt/cfg. So we need to give these as the parameters when running the Kubebench command. And we need to redirect the URL to this particular file. All right. Does the destination file exist? Let's quickly check that. No, it doesn't. So first we will create this file location. Let's make this file location. All right. Now let's see if we have let's just see where we are right now. We are on the /root. Let's just see if we have /opt folder. We do. So this is where we need to install the Kubebench. So let's open the installation docs. So there are 2 ways to install it. We will follow the Kubebench binary approach. So let's copy these commands and run them in the /opt. So hopefully our Kubebench should be set up now. And to run the Kubebench, uh, this is the command. So as I said, it will be expecting a CFG folder in the current directory, which is PWD is basically present working directory, and a config YAML as well. So let's run this command. Yes, it is generating report, but we need to, as per the question, we need to save this report into this file. So let's redirect the output to this file. All right. So maybe we can close the installation document since the documentation is complete. We can also run the check button on the lab just to see that first part of the problem is solved or not. Yes, it is. Both are coming green ticked and the Kubebench section is also in green. So Kubebench is installed. We have generated the report. Let's proceed to look at the issues and go about fixing them. So how do we go about approaching the issues highlighted by the Kubebench? Let's pick up this first one. Pretty easy to fix. 1.1.12, it says that ensure etcd directory ownership is set to etcd colon etcd. So, and if you go down, it will give a detailed explanation as to what you need to fix. Let's go down. There you see 1.12. It says on etcd server node, get the etcd directory and pass. Basically, this data directory is passed as minus minus data dir. You can run this command to check the data directory, or you can look into the etcd manifest YAML as well, and then run this command to change the ownership. So maybe let's quickly go to the manifest, sorry, etc kuber. So one should remember this path by heart. If I do ls, there is the etcd YAML. Data directory is var-lib etcd, and the same as the example given here. So we basically just need to run this chown command. Let's do that. All right. Let's run the Kubebench again just to see that this error is gone. 1.1.12. So let's run it, store it in the file, and then we'll look at in the file itself. Okay. It is still, yes, there you see 1.1.12 is now coming with pass. It's no longer failed. So we have fixed one issue already. And just to make sure that etcd pod is all working fine, we are in the kube system namespace. And you see that, yeah, nothing is broken and etcd pod is also healthy. Good. Maybe we can see if we have fixed all the issues related to etcd by hitting the check button on the lab. Yes, etcd is done. So let's proceed to other issues. We have one failure here on the node level. So node is kubelet. We'll come to kubelet later. So let's skip over. These are summary sections for various components. So etcd you can see right now is all pass, no fail. We have 10 fail on the summary of master. So let's pick up these. So yeah, these are the failures. Let's look at the first one. ensure that kubelet certificate authority argument is set. Let's look at that 1.2.6. So it says that in the API server, the kubelet certificate authority should be set. So let's look at the API server YAML. So we have kubelet client certificate and key set, but not the CA cert. So maybe let's create an entry for the CA cert as well. Let's try and locate the CA cert first. So the client certificates are being taken from this directory. So maybe let's cd into it and see if we can locate our CA cert. There it is. We have a CA cert here. So let's use it. Let's say this path ca.crt. All right. So we have fixed one issue related to the API server. Let's see some more failures if there are more things to fix for the API server. Yes, admission control plugin port security policy to be set. So let's look at 1.2.16. It says that in API server, enable admission plugin, we should have port security policy set. Let's do that as well. In the API server YAML, and there it is, enable admission plugin. So let's just add port security policy. Yes, we have done that. Let's look at some of the other errors now. These are related to the audit log thing. So let's look at all the four issues together. Audit log path, audit log max age, max backup, and max size to be set. So let's go to 1.2.22 onwards. All right. It says that audit log path should be set. Now this change will prop has the potential of breaking the API server. So we'll let it break and we'll see how we go about finding the issue and fixing it. But for now, let's just setting the audit log related parameters and let's see what happens once we do that. Setting max age, max backup, audit log path, and the max size. Let's look if there are any other issues reported with the API server. Ensure that insecure port argument is set to 0. So let's see what that is. 1.2.19. 1.2.19. Okay, it says that in the API server itself, we should have insecure port set to 0. So let's add that as well. We should try to add parameters trying to following the alphabetic order. So we'll add it here. All right, insecure port looks good. Any other issues? Yes, 1.41 profiling argument should be set to false. For detailed explanation, let's go down as always. 141. Yes, in the ABA, in it is talking about kube scheduler. We'll come to scheduler later. Anything more related to, do we see anything more related to API server? Probably this one, profiling argument 1 to 21. Let's see. Yeah, on API server also we need to set this profiling argument to false. So let's do that. Let's just now try to save this YAML. It's a static pod for API server, so it should start applying the changes. Let's just see whether the cluster is still operational or not. If I do get pod, we are already in the kube system namespace. If I do kubectl get pod, it should return the status, but right now it says connection refused. So our API server is not up yet. You can wait for some time, but if it is still not coming up, then we need to debug what's wrong with our API server. So let's go about doing some debugging here. Let's go to the third terminal and let's go to this path. /log. We are in where log pods path. Again, a path that you should learn by heart. If you do ls, you see log folders for different components. Which one is the API server one? Yeah, this one has API server. So let's go into this directory. ls cd kube API server ls cat3.log. So you see the log of API server. It says that it is not able to open var log API server audit.log. No such file or directory. So we have added this audit log path, but it is not able to open it. So we need to check, is this path even mounted? Probably it is not. So let's go back to our VI editor and open the kube API server YAML. So this is how you go about debugging the API server in case you have broken it with your changes. So this is the property that we had set, var log API server audit.log, but is it mounted as a path, as a volume mount? Let's go down. We see it's not mounted as a volume mount, neither there's any volume created for it. So let's create volume for this file location. Let's give it any name. Let's say audit-log. Type would be file or create. And actually, we first need to give host path. It will be a host path kind of a volume mount. So host path type, and then of course the path. So path, let's give the entire path where /log /API server dot log. correction, API server slash audit.log. All right. So we have specified the volume section. Now let's mount this volume as well. In the volume mounts, let's say name is audit log, and then the mount path. In the mount path, let's just copy this entire thing. And all right, hopefully this should be good. Let's save this uh, file escape:/wq, and let's see if it brings our cluster back up. Nothing happening yet, so maybe let's check the logs again. Not much clear from here. Let's go out and see. So if I list these directories again, something strange has happened. There is no API server named directory. So previously there was an API server directory, but now I don't see it. What that means is that the kubelet is trying to create the API server pod, but it is probably crashing repeatedly, and hence we don't see any logs getting generated. So now we have to do the next level of debugging. We need to check the kubelet logs and see what it says for the API server. So the command for that would be, let me just paste it here, general ctl -fu kubelet, and you grab the API server. Enter and just wait for few seconds, 30 to 60 seconds for something to show up here. As and when kubelet tries to restart the API server, let's see if it is facing some error. There you see error has popped up, and the error says open varlog API server audit.log, no such file or directory. Okay, so we have specified this path as volume mount in our YAML for API server, but does this path exist on our host machine? Let's check that. Let me just try to cat this file. There you go. No such file or directory. So let's first create this location. And just for the sake of it, maybe just create this file as well using touch command. It should create a blank file for us. Now let's see if these errors go away. These two are old ones when it was trying to restart and facing this path error. Hopefully this error should go away now. Or if there's any more issues, then they will pop up and we'll fix them accordingly. API server not yet back up. So there you go. Different logs have popped up. So the previous error is gone. Let's check if our cluster is back up or not. There it is. Our API server is back healthy. So we see how we go about debugging the API server. Um, Good to create some errors and go about fixing them. Okay, let's just run the report again. I'm running it without putting in the file for now, because if you run this Kubebench directly on the console, it will give you report with a nice color coding. Once everything is fixed, we will put everything back into the file again. Let's see from the top. So you see on the master, we have fixed everything related to API server. We can also go back to the lab challenge and check what the current status is. Hopefully API server should now come green. There you go. API server. If you click on API server, all the things related to API server are coming good. Um, Now let's head over to the other remaining issues. Okay, it says profiling 132, profiling argument to be set, and 141 again, profiling argument to be set. So probably different components. Let's first see 132. 132 says profiling argument to be set in kube controller YAML. So let's open the kube controller YAML this time and set the profiling argument. All right, and there was a profiling argument to be set in one more component, 141 issue. So let's go to 141. It talks about setting this argument in kube scheduler YAML. Let's do that. All right, let's just see the state of all these pods in the kube system namespace. They are all healthy, so all good. Let's go back to the lab and hit the check button to see how far we have progressed. Let's actually look at by running the kubebench command. So it looks very, very clean now. Only one failure, and that would probably be related to kubelet, as we have not fixed anything related to the nodes, the kubelet on the control plane and the node. So let's see where that failure is. Summary node. Yes, node one failure. Let's go and see what that failure is. 426. Ensure that protect kernel defaults argument is set to true. 426. Let's go for the explanation below. Okay. Now these are important lines. If you are using a kubelet config file, then edit it and add protect kernel defaults to true. If you are doing it directly via command line arguments, then in the kubelet service file on the worker node, on each worker node, you need to set this parameter. And then this is very, very important. Every time you make a change to kubelet, you need to restart the kubelet doing this systemctl daemon reload and systemctl restart kubelet service. So let's first see whether we are using kubelet config file. So let's go to this path. We uh, we are doing this on the control plane node for now, and then we'll do it on the node 01 worker node as well. Let's go to this path. Actually, it's a config file, so I can't cd into it. I need to cat the config file. So if you see that indeed we are using a kubelet config file, var lib kubelet config.yaml. So let's open this file. And let's just add this protect kernel default parameter in this config file. All right. Now let's do this for our worker node as well. You can get the node name using this command, kubectl get nodes. So let's SSH into node 01. Let's open the kubelet config here. And at the end, let's just add that parameter. You're in the node 01. So just exit out of it, come back to the control plane node. Let's just generate our report again. It is still showing as one failure. The important point to note here is we have done the change, but we did not restart our kubelet. There were specific instructions for that issue based on your system. Since we are running it as a service, we need to do these two things. So let's copy it. Let's do it on the control plane node, and let's do it on node 01 as well. So hopefully now this error should be gone. So looks like the issue is not yet resolved. We have done something wrong. So let's actually s- check our kubelet config again. Did we make any mistake? So it talked about setting this protect kernel defaults, but since we are putting it in the kubelet config YAML, this syntax is slightly wrong. There should not be hyphens. It should come as a camel case. So yeah, we have spotted our mistake. Let's try to fix this. Like I always say, it's good to make some mistakes when doing these demos so that we can learn from the errors that we are getting and go about fixing the issues. Again, let's do the kubelet restart thing. And you can also check the status of the kubelet, whether it is running fine or not, using systemctl status command. Yeah, it's in active state. Let's make the same fix in our node 01 worker node as well. So we go to the config.yaml and we fix the protect kernel defaults. And as always, very important step, let's restart the kubelet service. As an additional step, you can verify the status that kubelet is up and running. Yes, it's active. So let's run the report again and see whether we get all green or not. There you go. We have fixed all the failures that were reported by Kubebench. So as a last step, let's put this report back into the destination file as was mentioned initially in the question. Let's go back and check whether we have completed the lab or not. There you go. Everything is green and we have fixed it. Just to recap, in this video, we installed Kubebench utility from scratch. We ran the report. We identified issues related to various components of Kubernetes cluster. We went about fixing them. We saw that with API server, we introduced an issue due to which API server was not starting, it was crashing. We went about debugging that issue, how to check the logs of API server if it is crashing. And we went about fixing that. And then finally with kubelet, we learned few important paths where the kubelet configs are located. And we also learned that if you are making any change to kubelet, we need to restart the kubelet service. So that's about this lab. Thank you for watching this video. I'll see you in the next one.